Okay, so let's go ahead and get to the webinar. We're excited today to have David Church joining us to discuss traffic calming. So a little bit about David. David is a senior traffic engineer with WSP in their Kansas City, Missouri office, and where he's worked for the past 13 years. David received his bachelor's degree in civil engineering from Kansas State University in 1991. Before working for WSP, he worked at Caltrans in Northern California as a road design engineer before moving back to Kansas. David also spent 13 and a half years working for the Kansas Department of Transportation and the Bureau of Traffic Engineering in a variety of different roles. David specializes in the traffic safety aspects of transportation and is an 18-year member of the National Committee on Uniform Traffic Control Devices. David and his wife, Lori, have a son, Hunter, who recently graduated from the University of Kansas with a bachelor's degree in political science. Sounds like we're in great hands here, David. So without further ado, I'll turn it over to you.
Awesome. Thank you, Connor. And good morning, everybody. It's a pleasure to be here. And we're talking about one of my favorite topics, which is, how to make a transportation system better for not only motorists, but especially for pedestrians and bicyclists. So let's get started here. Okay, first I want to thank John Brown. John Brown is the project manager for the city of Hayes that is taking, he's been really the local champion for the North Vine Street project in Hayes that we're going to be talking about today. And this project wouldn't be where it is today without John Brown. So thanks to him. I also want to thank Kirk O'Michael. The North Vine Street project is currently under construction in year 2, and Kirk O'Michael is doing the construction engineering on the project, and Smoky Hill Construction out of Salina is doing the actual constructing. So they're the prime contractor. So this presentation is about traffic calming. And so I'm going to talk a little bit about, give an overview of traffic calming before we get into more about the North Vine Street project in Hayes. So what is traffic calming? Well, the ITE traffic, the definition in the ITE journal back in 1997, traffic calming is the combination of mainly physical measures that reduce the negative effects of motor vehicle use, alter driver behavior, and improve conditions for non-motorized street users. So it's using things that'll impact driver speeds like geometry or narrowing lanes, or either changing the vertical alignment or the horizontal alignment, things that are just going to get drivers to slow down. And what that does is that makes it more interactive with pedestrians and bicyclists and just makes things overall safer. And what I have here on the screen is a photo of some traffic circles in the Potwin Place neighborhood in Topeka. And the homes in this neighborhood were built in the late 1800s. And from my knowledge of this area, these were actually put in to do traffic calming for horse and buggy, so that horses that were pulling a buggy wouldn't just take off and and go loose through the neighborhood on these streets. And so literally they built these traffic circles, and these are brick streets for traffic calming, so it can control those horse and buggies. So traffic calming has been around a long time, and we'll go into more details here. So again, why would we do traffic calming? Well, when you control traffic speeds, if there are pedestrian or bicycle crashes, the chances of survival go way up if the speeds are low, and it just makes sense. So as the speeds come down, you have more non-severe injuries. As the speeds go up, you have more severe injuries. And then, up around 35 miles per hour and over, if you get hit, if you're a bicycle or a pedestrian, unless some, you know, certain circumstances arise, you know, it's not good. You know, it's probably going to end up in a fatality. So I've got a short video here that talks a little more about traffic calming. It's about 4 minutes long here.
Traffic calming is any change we make to a street so that motorists drive in a more civil fashion.
What that does is it signals to drivers that they need to slow down, be aware that they aren't dominant in a certain environment. And traffic calming is infrastructure to make sure that happens.
Is the infrastructure going to serve the pedestrian as well as the automobile, or is our pedestrian infrastructure going to continue to be shaved down so that more vehicles can move as fast as they want?
Adding bike lanes. Anytime we take some of the physical width out of the street, we're really doing traffic calming.
In New York City, they've recently released studies to show that streets that have bike lanes on them reduced killed or significant injured crashes between vehicles and pedestrians by up to 40%.
Traffic calming actually had its origins in the United States in Berkeley, or Donald Appleyard, the original researcher that did most of his work in Europe, brought traffic calming to the United States. We have many circles, a number of curb extensions, chicanes, through streets, and a whole other gaggle of different treatments have been tried and worked very well in Berkeley.
We were able to create this one-of-a-kind initiative on Marine Drive to radically narrow a street. Traffic would race down the street with huge population density on one side and all the Park District amenities on the other side of the street. So this obviously was a problem. So the street was narrowed and bump outs were created. It's reduced heat holding infrastructure. It's made a profound difference in the ability to get to and from the park. And it's beautiful. It has become a wonderful, wonderful model for the rest of the city.
In New Jersey, there's a state law that says you can't park within 25 feet of a crosswalk. These two orange poles that are installed on the street, one in front of me and one behind me, Hoboken daylighting poles, to physically prevent all but the most adamant drivers from parking in this location. The importance of that law and the importance of having these poles here is it improves the visibility between drivers coming down the roadway and pedestrians that are entering the crosswalk. I'm standing just on the edge of a bicycle lane that's 5 foot wide on a street that was previously 16 feet wide for travel lane. That 16-foot wide travel lane is actually wider than the travel lanes on the New Jersey Turnpike, which have design speeds of 75 to 80 miles an hour. We made the argument that by putting in a 5-foot wide bike lane, you squeeze the travel lane of vehicles down to 11 feet. That's a much more appropriate lane width for vehicles in an urban environment, and so it has an inherent traffic calming effect.
The great thing about the bike box is that, well, it provides a lot of visibility for cyclists at an intersection. It's actually a pedestrian improvement. So what it does is it sets up a nice hierarchy at every intersection in which they're applied. So you've got the nice crosswalk for pedestrians, and you've got the bike box for cyclists, and then you've got the motor vehicles who have to then stop at an advanced stop line back here. So it really sets up a great precedent for intersections, not just here on a living street, but for other streets as well. I'm sitting at the intersection of Bergen and Smith, which is actually the intersection of a community street and a living street. The DOT built a very large, what they call a neck down, sometimes called a bulb out or a curb extension here. Bulb outs are really beneficial because what they do is they allow pedestrians to be much more visible at intersections, and because they extend into the normal sort of street right-of-way. It also just provides more space, so it makes it more comfortable for pedestrians to be in the public realm, to be walking along our streets.
Signs don't do the job. That even having police officers on the corner do not do the job. Altering the infrastructure to, as we say, create an even playing field, to force traffic to behave in a more civilized manner is the way that it has to go.
All right, so that that video gave a good overview of traffic calming techniques and reasons why it's so important. And so I just wanted to note a lot of the examples that they showed in the video. For instance, these are, horizontal deflection are things that will cause vehicles to slow down. And here's an example of a chicane. So any type of lateral shift, realigned intersection or traffic circle, a modern roundabout or even a mini roundabout in more neighborhood areas, get the vehicle to change their horizontal direction. Also, getting the vehicle to change its vertical direction. So things like speed humps, speed cushions, speed tables. Here's a raised crosswalk example here, a raised intersection, anything that will get the driver to slow down because they feel like, they just feel like they need to go over the bump or the hump. Also, street width reduction. They talked about things like corner extensions or bulb outs at your intersections or crossings, chokers, median islands. Here's an example of a pedestrian crossing with a median island, which just allows some pedestrian refuge area through there, as well as some rectangular rapid flashing beacons. On-street parking, anything that narrows that driving environment is going to get the vehicle to slow down. And that's why people feel comfortable driving, 80 miles per hour on the interstate. It's wide open. And that's why you don't feel comfortable driving fast through the main street of a downtown city. And also just changing the intersection or changing the direction of the route entirely. So things like diagonal diverters. Now, this used to be an intersection that went straight through, but they've actually created some things here in the middle that would require drivers to turn left and turn right coming from this direction, but bicycles and pedestrians can get through. So anything like that is going to also slow vehicles down and divert traffic. So one example in kind of leading up to the Vine Street project that WSP has been involved with is a corridor in North Kansas City called Armour Road. And Armour Road is right in the downtown area of North Kansas City, but it's like a commercial area. And as you go east, it's essentially it's a MoDOT route as well that connects in with I-35 on the east side. So here you've got an arterial in a downtown city in Kansas City, a 4-lane section with left turn lanes. It's a signalized corridor. It has a lot of crashes. The vehicles per day is like 15,000 vehicles per day. That's a lot of traffic, quite a bit of traffic for an arterial of this type. And they really needed ped bike improvements and a need for traffic calming. So that was the before picture. Here's the after picture where they've converted it to a 3-lane section. They've included on-street parking. Traffic speeds have gone down by around 5 miles per hour. Crashes have been reduced and severity has been reduced. However, travel times remain the same, which is good. And there were some folks within North Kansas City that were very concerned that, okay, you're going to take a 4-lane and make it a 3-lane. You're taking away 2 through lanes of traffic. It slowed folks down, but it made things safer, but it didn't really change the travel time. And the benefit to cost of these improvements was around 18-1. Not only that, but you have a buffered bike lane on the other side of parking between the parking and the sidewalk. You also have some improved crosswalks with some bulb outs. And don't look at those pavement markings. I think they have some colored pavement markings out there. If you're a MUTCD aficionado, those don't meet the manual, but it's not something to be concerned about. Also, they had some bus only parking out there as well, which is great for transit. So they turned it into a complete street that was better for bikes, peds, and transit, as well as keeping it safer for motorists and just make it an overall more pleasant corridor to travel on. Okay, let's talk about City of Hayes and the North Vine Street project. So most of you, if you live in Kansas and you've been to Colorado or you've been out towards Western Kansas, you've probably stopped at Hayes. Hayes is the midpoint between Kansas City and Denver. And it seems like if you're traveling on I-70, no matter where you're coming from, you typically stop in Hayes to get gas or to get some food. And you stop on Vine Street, which is also US 183. And if you haven't spent much time in Hayes, maybe you visited, maybe you've stopped for gas or something. It has a really great culture. And I just wanted to share a little more about the culture of Hayes, Kansas.
Here in Hayes, we appreciate the little things, like a good meal shared with friends, and time outdoors that restores. We're also fans of the truly Hayes things, like our talents and our history. We love exploring the new things as well as the old. So spend some quality time in Hayes and enjoy the best things with us.
All right, and there was that little depiction of folks playing some instruments, and I'm not kidding. When, as part of the project, when we were out there one time, a group of us went to dinner downtown and came out of the restaurant, and all of a sudden we hear this music playing, and so we walk about half a block away, and there was a gazebo set up at the park, and the city band was playing a concert right there in the gazebo. And so we hung out there for a while and listened to the band. And, that's kind of a community that Hayes is. It's a college town with Fort Hayes University, and really just a great place to live and a great place to visit. So North Vine Street is, again, it's a major arterial through Hayes. It's also US 183. It has an interchange with I-70, which you can see in the photo here. So this is a part of the Vine Street corridor that's just south of I-70, all the way from 33rd and 32nd, which are two offset intersections that are signalized. You've got 35th Street that's right in the middle there, that's a two-way stop, and then 37th is also a two-way stop. And then you've got the two signals at the interchange. The box in red there is an old hotel that had become in disrepair. It was going to be torn down, and the city was interested in doing some redevelopment or working with folks to redevelop that property, because there's around 18,000 vehicles per day in this part of North Vine Street. And that's why, there's so many commercial businesses here. However, this is an old school design built in the 1960s, and it's a 4-lane facility with turn lanes, but it has frontage roads that are only like 1 car width away from the main road. And so when there wasn't much traffic through here, it's not a problem, but as traffic increased, it becomes a major problem. So north of I-70, North Vine Street has developed over the years, over the last 10 years or more, let's say. However, some really good planning went on here. And that's where the city was able to get some funding through KDOT to, instead of build frontage roads, to build backage roads. And that's what the roads paralleling Vine Street is backage roads, so that you have good access management off of North Vine. Your only connections are to the city streets, and then folks get access to the businesses via the backage roads instead of on North Vine Street. So very good planning north of I-70. But again, this is the intersection of 37th and Vine, right adjacent to that hotel that was needing to be redeveloped. And there's a lot of problems there. It's a two-way stop. You've got a roadway that comes in from the northeast and connects into North Vine as well. And during peak times of the day, it's just mass chaos here. And if you've ever been through there, you know what I'm talking about. So the city hired WSP to do a corridor study. Initially, it was just focused on 37th and Vine. However, it expanded all the way down to that intersection of 32nd and 33rd, all the way up north to 41st Street. And existing traffic was back in 2016, and planned future traffic was 2036. There's a lot of undeveloped property through here. And so we had to make assumptions on how that property would be developed, then create trips, and then distribute those trips along the Vine Street corridor so that we could do analysis on future conditions. And key challenges along North Vine Street, and this is what the 2012 comprehensive plan said, was the traffic system along North Vine Street is confusing to visitors. Its close frontage roads and inadequate stacking space produce numerous traffic conflicts and potential crash points. And they're not potential crash points, they're real crash points, because I'll show you later how many crashes we have along this corridor. Also, it's very non-pedestrian friendly. And we'll talk more about that here in a minute. So this is the intersection of 37th and Vine during a peak period. The main road is here. This is the closely spaced frontage road. And you try to figure out who's got the right of way in a situation like that, and it's hard to do. So I even saw some people that were trying to access Vine Street and just decided they couldn't. And they actually looked and backed out and just took the frontage road to some other connection. They're having traffic congestion during peak times. This is North Vine Street northbound during the PM peak, and you've got traffic backing up all the way past 37th. So when you back traffic up through the intersection of 37th, that's already a chaotic mess. It just makes things even worse. The other thing is that this is a route that oversized and overweight loads are routed through, permitted loads. So here's a wind blade that's on North Vine Street. So all that mixture of congestion and conflict points and so forth have resulted in 120 crashes during the time period that we looked at, 2012 to 2015, and resulting in 17 injuries along the corridor. And it included everything, there were crashes all along the corridor, mainly focused on those intersections. So we developed a VisSim model, a microsimulation model to model existing conditions. Currently, Vine Street's signed posted speed limit is 35 miles per hour, but really the operating speed is somewhere between 35 and 40. And when you start getting up in that 40 range again, the chances of having a fatality or serious injury with a pedestrian or bicyclist really goes up, just like we talked about. So anyway, we modeled existing conditions. Pedestrian movement is really restricted. There's a sidewalk on the east side of Vine Street. However, on the west side, there was no sidewalk. Buses would get off the interstate full of kids or the elderly. They would park on the frontage roads in these sandy areas where they had room to park a bus. And then unfortunately, they'd park on the on the west side, and then there's no mid-block crossings through here. So here you're having 20 or 30 kids that are trying to cross Vine Street because they want to go to McDonald's. The bus didn't park at McDonald's, and it makes you cringe. Every time I was out there and I saw that, it's like, oh my gosh, somebody is going to get hurt. Just not good at all. Economic development deterrence, because Vine Street had a reputation of being congested, it makes it harder for new developers to come in and want to redevelop there. So the need to do something was really imminent. So we looked at different alternatives. We looked at existing conditions. We looked at adding a signal at 37th Street and Vine, which just made it worse. And we also looked at some roundabout options. When we predicted average yearly crashes, existing was around 30 crashes per year on the corridor. And with roundabouts and using the highway safety manual, the number of crashes was going to be reduced in half, and the severity was going to be really reduced. And just looking at conflict points, you know, there's all sorts of conflict points along the corridor. And if you add in all the different types, the most important are the crossing, because those are where you have your T-bone angle accidents that'll result in higher injuries and fatalities, but a total of 237 conflict points. So you can see existing conditions from 237 to more of a signalized intersection option, which reduced it some, to more of a corridor, a roundabout corridor option, which reduced conflict points by 55%, and crossing conflicts from 133 to 38, which is amazing. So what came out of the study was that, you know, you needed to still have mobility in the corridor. The city realized it's the gateway to the city, and you want to have good access to businesses, but you need to have good pedestrian mobility, which they really did not have at all. And number one was improving safety. So the city hired WSP to start in on the design of an improvement project. And this is the roundabout corridor that we came up with. And we'll go through this kind of piece by piece. So the design criteria, we had to use the Kansas Roundabout Guide. The toughest thing we had to do was to design this to handle large semi-commercial vehicles, WB67s that are, you know, right on the interstate, side by side through the roundabouts. So we had to make the lanes a little wider in the roundabouts to accommodate that. And also we had to accommodate wind blades or wind tower sections that would take up, you know, 2 lanes through the roundabouts. We did fastest path analysis. We worked with KDOT and the FHWA and decided to use rectangular rapid flashing beacons at all the multi-lane crossings on the corridor. And also we had quality control review of our plans and any documents that we had by Kittleson and Associates, who are national roundabout experts. So here's some of our fastest paths analysis, and you're trying to keep, you're analyzing the speeds coming into the roundabouts, going through, and then coming out. And all those are important because you've got your crossings at your entry and exits. And again, fastest path analysis is using the entire pavement section. So you're saying that a vehicle is going to not stay in their lane, they're going to switch lanes and just use the fastest path to get through. So we had to make sure the roundabouts could handle trucks, but keep the fastest path speeds down on all those entry and exit and circulating points. So if we look at the area around the I-70 interchange, we've got 41st Street or Mopar Drive just north of I-70. this was only a right in, right out access. But the city talked to KDOT and was able to get permission to open this up, which is going to open up opportunities for development to the east and west of Mopar Drive. And the interesting thing is what we did for the westbound exit to Vine was, instead of putting a roundabout here as well, we're getting folks lined up in the proper lanes on the ramp, and then everybody has to turn right. And so if you want to go south on Vine, you're going to get on the inside off-ramp lane, turn right, make the U-turn at the roundabout at Mopar Drive, and then come south. And if you want to go through, or if you want to turn right, you just get in the right lane. So we have overhead signs that are going to tell people which lane they need to be in, as well as signs here in the median. So we have this. We also have a teardrop roundabout at the off-ramp, and then here's our 37th Street intersection with 37th Street extending to the west, and we'll talk more about that in a minute. So, yep, we talked about Mopar Drive here and what that does. Then the teardrop. And then here's the roundabout at 37th, which started the whole study. And the cool thing is, and this matched up with their 2012 comprehensive plan, was we extended 37th to Skyline Drive, which is a residential neighborhood. We also took 41st Street, which did come down and intersect right through here, and tied it into Skyline Drive up here. So all these folks from the neighborhood are going to have great pedestrian and bicycle access to the Vine Street corridor, which previously they just didn't have access to. So now that they can walk, they can bike, and it's tied into a much more connected pedestrian and bicycle system. Then as we go south, we have the intersection with 35th Street. This is a what's called a three-quarter access, which means that you can turn left off of Vine Street into the development, but you can't turn left out. You have to turn right out of 35th Street. But the cool thing is, and we got the idea for this from a webinar that was done around this time on access management and roundabouts. This is a great mixture of access management and roundabouts, where the folks turning right can make the U-turn if they want to go south on Vine. And the same thing coming from the west as well. You turn right, and if you want to make a U-turn, you go through this roundabout and come back. So we're essentially creating a system here that not only is cutting down conflict points, but it really is restricting left turns. And it's basically making those right turn U-turns. And then the final roundabout on the south end, where we had two signals, is what we call this hourglass shape roundabout. And this is very unique. It's one of the only multi-lane roundabouts of this type that we know of. I think we found one other back east, but most that are shaped this way are just single lane. And so we felt like this was really going to improve traffic flow, but also with the pedestrian crossings, improve safety for folks crossing down at this intersection or these intersections. So just a little bit, we went ahead and modeled, we used VisSim to model what it would look like to drive through the corridor with roundabouts. And essentially what we're doing with regard to traffic calming is changing the horizontal direction of traffic such that this is a much more curvy corridor instead of a straight corridor. And when you get this driver's eye view, that's exactly what it is. Now, there are some tangent sections in between the roundabouts. However, we do have some mid-block crossings that are going to get the driver's attention, and then we're going right back into another roundabout. This is at 37th Street here. So just by changing the horizontal position of the vehicle, the drivers are having to slow down. We think that this is going to divert a lot of trucks. When the Vine Street project won a build grant in 2018, the very next year, the county won a build grant to complete a 183 bypass on the, I guess, to the north and west. So Hayes right now has a 183 bypass that goes from Vine on the south up to I-70 on the west, but it hadn't been completed. And so that northwest bypass is being constructed right now. And we feel like the changes here are going to divert trucks and some of those oversized loads to be able to use the bypass and really reduce the amount of trucks we have here on, on the North Vine Street corridor. So we did help the city apply for a build grant in 2018, of which the city took the lead on a lot of the getting the letters of recommendation and doing the public outreach and all that. And we found out later in 2018 that they were selected for a build grant, a federal build grant in the amount of just over $6 million. This project was let to a contractor in, would have been March of 2020, right when the pandemic was starting to hit. And so not the best time. There was a great deal of, half the plan set was temporary traffic control plans because the city was not going to allow the closure of on and off ramps. They wanted things phased very specifically such that you could keep traffic flowing during construction. And so with all that detail, it left little flexibility to the contractor. So we think we saw some increased bids for that, as well as the uncertainty with regard to materials costs and other things with regard to the pandemic that was getting ready to hit. So just to carry through a little bit on construction, then I want to show a couple of videos. It's a 2-year construction phase. The first year focused on 32nd and 33rd Street down on the south end, and building the West Frontage Road, tying in 41st Street and extending 37th Street. Kirk and Michael has a drone that they would fly the corridor every week and take drone photos of construction. This is year 1 starting. And you can see them constructing the roundabouts there at 32nd and 33rd Street. So the curvy, Vine Street's starting to look curvy through here while they have traffic on the other side. And this is what the 32nd and 33rd Street roundabout looks when they completed it in December of 2020. And that was the first roundabout to open up. So just want to share a second of the day that the roundabout opened. I can't tell you how satisfying it is to see. I just, when roundabouts are used properly, they really work well. And to see traffic slowing down through here, and it's just, when they say traffic calming, to me, it's just much more calming to watch traffic through here, to drive through here. And you can see the semi getting through. And so as a traffic engineer, it's just an amazing thing to see that what you planned and modeled and hoped would work, is actually works. And you can see traffic is kind of staying out of the way of that semi, which I would too. So this video is on YouTube. If you just look up, North Street Roundabout, North Vine Street Roundabout, you can find it pretty easily. So now the project's in the second year of construction. It's focused on building the roundabouts at 37th, at the eastbound off-ramp, and at 41st Street, as well as the westbound off-ramp realignment. Here's some recent photos of that construction. And right now they have traffic, one lane in each direction on Vine Street. And it's really working well. And the thing I love about it is it's training folks to drive through the corridor without them even knowing that they're being trained, because they're having to drive through these these partial roundabouts as they're being constructed. They're having to slow down. There's no left turn signs all over the place. So if you come off an off ramp, you have to turn right. You have to go down to the roundabout on the south end to make a U-turn. And it's just amazing that, how it works that way. But what it's also done is it's allowed the city and property owners to get more redevelopment along the corridor. So this is actually some new buildings and new businesses north of I-70 on the west side of the corridor, which is great to see. You see many more sidewalks this is the sidewalk on 37th tying into the neighborhood to the west. We left a segment of 41st Street there instead of tearing it out, and it's only going to be for bikes and peds only. So that's the photo on the right. So vehicles can't drive on that. That's only for bikes and peds. More sidewalk, lots and lots of sidewalk. We have some mid-block crossings that are going to have RRFBs. Just wanted to share this video real quick. This is at a ground view of the roundabout there on the
people turning into
on the south end.
Instead of that.
And again, folks are slowing down to get through, which is improving things for bikes and peds. I think just prior to me shooting this, I saw some peds using the crossing to the south there, where the pedestrian signs are, and traffic, it's a rectangular rapid flashing beacon, so it flashes and vehicles stopped and let them go ahead and cross very easily. So I was real happy with what I was seeing out there. Here's a pedestrian crossing at the south roundabout, as well as some more bike and pedestrian infrastructure. This is 35th Street, where folks are having to turn, right in, right out. And real quick, I'm going to show part of this, and then we'll open it up to questions. So this is me starting up at the signal at 43rd Street, up just north of our corridor here. And the most delay I had in shooting this video was at this traffic signal. So you can see once I start driving through the project, just how curvy Vine Street is going to be. And what we're going to ask KDOT to do is do some speed studies afterwards and see if there's a potential for lowering the speed limit from 35 to 30 miles per hour, just because people have changed their operating speeds. So you can see all the no left turn signs. We're going through the part of the teardrop that's been constructed. There's the Hayes sign with a bunch of students climbing on it. Here we're getting ready to go through the 37th Street roundabout. And again, this is one lane each direction. So with 18,000 vehicles per day, it's really working really well. And this was on a Saturday afternoon in the peak of vacation season. So a ton of the plates you see here are folks from Colorado or other places across the country that are just stopping in Hayes again to get gas or get something to eat over the lunch hour. So there's the 35th Street intersection. Right now they're allowing northbound lefts in, but southbound lefts are not being allowed currently. Now we're getting ready to go through the teardrop roundabout. So I want to make the U-turn and go north. And I really want to encourage others to think about using these type of strategies to make improvements to your arterials, because when you do crash analysis within a city, most of your crashes happen on your arterials and not as much on your collectors and your local roads. And so if there's a way that you can cut your conflict points down by a half or more and lower speeds and still get people through and still allow access to businesses, then that's just a benefit for everyone. And I think, and hats off to the city of Hayes for taking this giant leap, because at the public meeting, we met with folks and they were generally okay with the concept. It's just they said, why didn't you just pick one intersection to build a roundabout? And why are you doing a whole corridor? Because we're not quite ready for that. But, it looks, folks are driving through it really well. It looks like it's so far so good. So anyway, I just want to thank a lot of folks at KDOT and the FHWA for all their support of this project, because it was a real leap of faith to make these improvements to a major arterial that's also a state highway and to do traffic calming. And so I just like to open it up to any questions that anybody might have.
Thanks, David. It does look like we've got a few questions here in the chat.
Okay.
So Nelda asked, I haven't seen many raised crosswalks used much. Excuse me. Are there downsides, drainage issues with that?
Yeah, that's a great question, Nelda. I think and I've seen some raised crosswalks used on some local streets where there's issues with cut through traffic and stuff like that. But definitely, I would think that they would have to do quite an analysis to make sure that the drainage was not going to be an issue, and hopefully, things could drain either side of that raised crosswalk versus trying to, drain from one side to the other. So yeah, if you want more information about that, I'd be happy to send you some examples, and I know that they are very effective with getting folks to slow down through the crossing area. But great question about how drainage would take place through there.
All right, it looks like we've got another question here from Mike Spatafor, asking about the Armour Road project and just how is that benefit to cost value calculated?
Well, that's a great question, Mike. So in the study that we did, what we did was we used the highway safety manual to predict what the crashes would be after the improvements were made. And I believe it was after all of the phases of the improvements were made, just not, let's say, phase 1 or phase 2, but I think there's all the way to phase 4. And based on that crash reduction, and also using the highway safety manual to show the reduction in severity of crashes, we use the FHWA crash costs that relate to those different severity values. And over the life of the project, which is 20 years, then we knew the cost of construction of all 4 phases. We knew the benefits to safety over that 20-year period. And so essentially at that point, you have your benefit over your cost. And so that's how we got to around 18 to 1. And we'd be happy to share a copy of that study, or you could request one from the city of North Kansas City as well.
All right, looks like our next question is from Lisa Koch. And just what was the response from the public? And how is the public informed of how to use this new roundabout system?
Oh, great question, Lisa. Initially, folks were a little bit apprehensive. However, the city of Hayes did a tremendous job with public outreach. They actually took the lead on the public meeting during design and did a tremendous job. They have a whole website set up that people can go to on how to drive roundabouts, how to drive these roundabouts. There were some business owners along the corridor that had some real concerns about folks not being able to get to their business during construction, or people just avoiding Vine Street after construction. And I don't think they'd mind, but the Pheasant Run restaurant, which is at the corner of 32nd and Vine, is like right on that hourglass shaped roundabout. And actually it affected some of their parking because we cut off the frontage road that used to go through there. When I was at the public meeting, they were in tears talking with me because of how it's a family-owned business that's been there for years. And they were real concerned about this project and the impact on their business. And I was so happy to see that when I went through earlier this month, that parking lot was full. It looks like things are going well. Folks were getting in and out just fine. The other thing I heard from Kevin Zimmer, who's the area engineer at KDOT, was that, and knock on wood, that since that south roundabout's opened, that the city of Hayes has not received one complaint call from a person that lives in the city of Hayes about that roundabout. So I think it's been real positive so far, and we'll hope that continues.
All right, looks like we've got a question from Andy Fry asking if you have any other drone footage or footage of bikes and pedestrians navigating the corridor.
Absolutely, Andy. I will email you a link to the website where the city's posting their overhead aerials, and I think where they have some of the latest drone videos, and I'll confirm that with Kirk and Michael, but I'll send you a copy of that, Andy.
And we've got one final question here from Jeff Woodward, and that's just, when will the project be complete?
Oh, awesome. I didn't even say that. So the project will be complete in November of 2021 this year. And from what I know, from what I hear, the contractor's on schedule for completion, this November. And I would just encourage folks that if you're in the Hayes area to please exit at Vine Street and try out the corridor yourself, see how it feels to drive through. Let me know if it's intuitive, if you have any comments or anything, and even go park and use some of the crossings and just provide any feedback, because I know that'd be important to me, it'd be important to the city of Hayes and important to KDOT. And we're just hoping for the very best, but that this is going to be a much safer, a much more pedestrian and bicycle friendly corridor that still is good for economic development and that others can use as an example.
Thanks, David. Do we have any other final questions before we wrap up here? Okay, seeing none, I'd just like to thank David again for the great presentation, and thank you all for coming. Just a reminder that the KUTC will be hosting these webinars monthly, so keep a lookout in your inboxes for the next one. And with that, we'll just go ahead and finish it up here. Thanks, David.
Thank you, Connor. Thank you, everybody.
Yeah, have a nice day, everyone.